Before we begin this Microsoft Digital event, we would like to acknowledge the traditional custodians of the land on which we live and work throughout Australia, as well as the Aboriginal and Torres Strait Islander people viewing this event today. We pay our respects to elders both past, present and emerging, and recognise and celebrate their continuing connection to land, waters and community. Our reverence also extends to all First Nation and Indigenous peoples, as well as their ancestral lands.
Hi everybody and welcome to New Breakpoint. My name's Simon Waite. On today's show we've got an amazing topic on the concept of chaos engineering. It's an interesting space, so I hope you hang around. We'll have a live Q&A at the end of the show today. Best questions during the show will be answered live with my guest Martin Abbott, and any questions that we don't get to, we will put them into the show notes, which the link for will be published during the episode in the Q&A window, so keep an eye out for that. If you do want to share today's episode with your colleagues or your community, you'll be able to access the link for that in an email that will be sent to you 2 to 3 days after today's episode. So keep an eye out for that. So my guest for today is a longtime friend and former MVP, Martin Abbott, who now works for our Microsoft team in Perth as a digital and app innovation specialist who focuses on helping our customers get the most out of the Azure platform when it comes to designing, building and running their applications. He's going to talk about Chaos Studio. It's a fascinating topic, chaos engineering, and the tooling that's coming out in this space, particularly from Microsoft, is going to allow people to build more resilient applications as they bring them onto commoditized services running on a cloud platform like Microsoft Azure. I don't want to steal too much of Martin's thunder, so let's get him onto the show for a quick intro and then we'll be into it. All right, so now I'm joined by my guest for today, Martin Abbott. Hi, Martin, and welcome to New Breakpoint.
Thank you, Simon. Thank you for having me.
Look, it's an interesting topic, chaos engineering, but do you want to tell us a bit about who you are, your role, and the topic for today?
Yeah, so hello, my name is Martin Abbott. So I'm we've changed our title recently. It's the rather grand title of Azure Digital and Application Innovation Specialist, or App Innovation Specialist, it's just a bit shorter. I always say that you can't talk about digital transformation without the word digital and innovation in your title, so that's all very good. My role really is to help customers with the application portfolio of Microsoft Azure. So that's everything from app services through to integration. Obviously, Chaos Studio will play a part in that as well. Some stuff around containers as well and AKS, but also the dev tooling around Visual Studio Code and Visual Studio and all that good stuff.
So chaos engineering, I'm not going to steal too much of what you're going to give away during the talk today. Do you want to tell us a little bit about chaos engineering, where it comes from, why it's important?
Well, I can, and we can move to my first slide, which describes that perfectly if you prefer. But yeah, I mean, it's essentially chaos engineering. It's I guess you could argue it's an emerging practice in environments. I think anybody who's been around the world of software development and actually just general delivery of complex software has probably heard the story about Netflix. So when Netflix moved their code from their own systems to the cloud, they realized that, of course, in the cloud, some things break. And the best way of making sure that they built a resilient system was to build some tooling around that. And again, anybody who's been around this space has probably heard of Chaos Monkey. Chaos Monkey was some tooling that they built to just randomly inject faults and dependencies, so timing, delays, and so on and so forth, to try and understand where they would get problems should such a thing occur, which of course it can in the fullness of time. And I think basically is when you build that sort of thing, having that understanding is vitally important because, of course, that helps you build a better system going forwards.
All right, look, fascinating topic. I'm conscious that we're kind of eating directly into your ability to demo Chaos Studio and talk a bit more about this. So I'm going to hop off. I'll be back later for the live Q&A. Make sure you ask any questions in the Q&A window during the show. But in the meantime, over to you, Martin, and I'll be back later.
Okay, thank you, Simon. So I think the key point about chaos engineering really is this cycle. Okay, so you can imagine an environment where you've got a complex solution. That complex solution is inevitably going to be made up of services, VMs, other pieces of software, and you want to be able to understand what will happen should something egregious happen in your environment. So you'll probably start with a hypothesis. What happens when this happens? So that leads to the idea of an experiment. So you'll create your experiment, you'll run your experiment, you'll look at the telemetry and everything else that comes out of that experiment, and you'll analyze that data. And as a result of analyzing that data, you'll get some insights into your solution and therefore be able to hopefully improve the outcomes going forwards. The key part of this is really making sure that your system is reliable. And another part of this, of course, is that this job is never done, right? So you'll be building different parts of your software, you'll be creating new versions and so on, but you'll also come up against things when you've done production for a while and things happen, and you'll hypothesize based on the outcomes of just ongoing running of your production system. So all these things form this cycle of chaos engineering. I mentioned before that Netflix created this thing called Chaos Monkey, and this is kind of exactly the sort of thing that they did. It's here we are, we've got this big streaming service. What happens should a data center go out? What happens if this particular really important part of the system fails for any reason? How can we recover from that? Or more importantly, how can we make it reliable so as we don't have to recover from those situations? And all of this is, you can see here sort of that hypothesis, experiment, analyze, improve. That's kind of a scientific approach, which is what we want. We want that key aspect of being able to provide repeatability of the outcome, because that's an important part of being able to get value out of that analysis phase. So what is resilience and what is quality? So essentially, I think here we've got, I think this, put out a slide here. So really what resilience is it's the capability of a system to handle and recover from disruptions. Now, why do we care? We care because service outages impact availability. And they impact availability because, of course, when something goes wrong, your customers can't use the system. And it's important to think about what customer means in this particular concept. Customer is not just a person out there in the real world who is using your system. A customer could be an internal person. It could be your legal department who need access to something. But when they get upset, but it's not only them getting upset, and that is a key part of resilience and quality. We have to understand that there can be serious business impact when things go wrong. Now, whether that's something such as financial, I mean, we've all seen the things that happen during the crazy days of Black Friday and others, where things get hit very heavily and things go down. If you can't transact, that can create a financial impact. Maybe you're a large-scale auditing company who's being audited themselves, and if you don't have access to your systems, that can create very bad legal ramifications. Even more, what if you're a fire service and you can't dispatch trucks because something's gone wrong? So you can see all these things that when you want availability, because unavailability causes a business impact. That's not good for anybody. And then at the end of the day, you really want to make sure that you're being kind to your customers and making sure that they have the system that they want, because there are serious ramifications if they don't. Beyond that, of course, even with these systems, it's important to understand that these systems are built by people and they're operated by people. When things go wrong, those people are also impacted. So it's not just your customers, it's everybody in that chain that's part of that delivery of that software or hardware. So it's important to understand that those outages also take time away from developers who have to fix bugs, from operations staff who have to find out what went wrong and report on it. And then obviously, as you rev new features, you want to be able to make sure that you understand the impact of those features across the lifetime of the software. So the key thing there really is that these quality practices, these things that help you understand and define what is going on in your system and your service, need to be built in from day one to make sure that you can understand all the aspects of your solution, through that entire development and operational lifecycle. And it's very critical to do that sort of stuff, because if you don't do that, then as you can see from the left-hand side, you get service outages, which causes impact to your business. So why is this kind of important now rather than 20, 30 years ago? Well, part of it's to do with the fact that we have the cloud now. So cloud has many, many benefits, of course, whether that's through abstraction of management and maintenance and that sort of stuff, or whether it's, if you're using PaaS services, even further, going through to your networking and your compute layers as well. So we have, as a result of that, of course, lots of benefit, the ability to run these things without some degree of responsibility, but we also have less responsibility and less hands-on, and therefore it's harder for us to understand when things go wrong. So being able to test things and test outcomes is an important aspect of that, because if you are running your system in a cloud, say Microsoft Azure, of course, and something goes wrong, you want to be able to understand what's gone wrong. Now, we produce great metrics when it comes to things that happen in Azure, but of course, what we no longer have is that ability to see that information right then and there when it's happening, because we're not in control of those services like we would be if they were in our own data center. So our ability to have control and understand the resolution of that is diminished as a result of having less control over the overall infrastructure. But of course, that's just the cloud side of things. We're also responsible for the application that we're building and producing and putting onto that cloud. So if we build bad software, that's going to impact the business as well. Now, that kind of leads us to the idea that about that resilience becoming that shared responsibility. The cloud provider providing resilience in their infrastructure, and the application providing resilience when it's built onto that infrastructure. So that's good, but beyond that, it's really useful to be able to test what we're doing. And that's really where we provide tooling, and obviously in our case, that's going to be Chaos Studio. So that's where we provide tooling to allow you to then test these hypotheses and allow you to understand things so you can build in that resilience. So the point there really, again, is that we have resilience in the cloud to a degree with the Azure infrastructure that underlies all the services that you're there, and there's obviously service level agreements around all those sorts of things. But there is a shared responsibility to make sure that everybody is doing the right thing, to make sure that things are working and running correctly. And Azure Chaos Studio is the tool that we provide to help you do that. So a few scenarios here about chaos engineering. I think it's key and important to understand the left-hand side and the right-hand side. So the right-hand side, you could probably consider to be more the production end. And very typically, site reliability engineers go, if you're not testing it in production, you're not doing a real job. So you can see there, maybe you're testing in production, you're doing business continuity testing or high availability testing, that sort of thing. But of course, when we want to shift left and go down to the other side, it's also important for us to understand, and remember I mentioned earlier in the previous slide, that we have this need to be able to look at this thing across the entire life cycle of the application. So it's also important to go down to the other side, to shift left and look at how we can test that stuff in environments that are not production environments. Now, in those environments, of course, it gets even better, because then we can build that into our CI/CD processes so that we can do some testing, and as a result of that testing, either fix or in fact provide some kind of gated output to a production environment, because at that point we know and we're happy that things have gone well. But chaos engineering is not just unplugging a computer. It needs much more rigor around it than just that, and that's the key part of where Azure Chaos Studio can be brought in and provide that more control over your testing. Just one second. Excuse me. So what is Chaos Studio? So it's a tool to measure, understand, improve, and maintain product resilience. It's a fully managed service. It's already available in the Azure portal. If you go to the main portal page, there's a big red symbol like was on the intro screen. Click that, and it opens up a new studio. Opens up a new blade into a new studio. And it's built with the idea of testing the resilience of those Azure services. Not surprisingly, it's deeply integrated. So there's ARM template control for all this sort of stuff. I'm going to show something actually in Bicep in a little while, and reporting out to monitor, and obviously integration in terms of access. It's worth pointing out that there is an expanding library of faults. So that at the moment it doesn't cover everything, and I'll go into what it does cover. But obviously the key point here is that going forwards it will cover more. Simulation, of course, that's the whole point. That's the experimentation. So the idea there is to come up with that hypothesis and then inject a bunch of stuff into your environment to make sure that your hypothesis is safe. And the other aspect of that is that when you're running an experiment, if something is going wrong and causing serious problems, you can actually just stop that and roll back the experiment to make sure that you're not impacting or potentially impacting operational sides of things. I mean, obviously, the general rule is you wouldn't be doing this in the middle of Black Friday. So you know, you try and schedule these things for when it's safe to do so. So the unit, I guess, of all of that, and again, recall that cycle, which was hypothesis, experiment, analyze, and improve. The unit really is this concept of an experiment. So what is an experiment? It is an orchestrated scenario. And you have the concept of targets. So I'm going to go bottom up from here. The targets, which would be things like a VM scale set, for instance. And again, we'll look at those when we go to the portal. You select a group of those targets that you may want to impact. You'll have an action, which might be a specific fault, or you might want to add some latency or change security, that sort of thing. You can have branches in these experiments, so you can run parallels actions within a single experiment. And of course, if you've got a complex system, that's going to be pretty important. And then within those branches, you have steps that are the things that actually do the work. So going back down, steps, branches, actions, selectors, targets. That's actually pretty simple. And actually to run the experiments is pretty simple. And obviously the trick is creating experiments that have value. That's where the hypothesis comes in. If you've got a good hypothesis, I want to know what happens when I take out 2 of these instances, because I need to understand what will happen when those instances are down. Do I still get pages served, for instance, from a web farm? Then you can start building out that experiment. And then obviously there's no reason why you can't test that experiment, analyze it, and improve that experiment. Not just improve your system, but improve the experiment, because that's actually all part of that scientific method. We experiment. If the experiment is not a good experiment, then can we re-experiment again. So what does it look like in reality? This is kind of like just a very simple breakdown. So we go bottom up, fault library. So what can we do? The experiments, that goes into the chaos provider. That chaos provider can be managed either through the portal or through a REST API. So it is all ARM template ready. We have this concept of service direct control of faults, which is obviously directly against specific infrastructure inside Azure, and then agent-based. So if you've got, say, a virtual machine, you can inject an agent into that virtual machine, and it can do work within that agent, within that virtual machine directly to help you control the faults. So what are there in the fault library? I'll probably just step through this one quite quickly because the more interesting stuff is coming. So there's an expanding list. So we can put stuff in our code, guest OS, Azure resource and infrastructure. At the moment, it's somewhat limited in terms of what we can do in terms of the Azure resources, and we'll look to see what those currently are. But essentially, you have this concept of injecting faults or injecting time delays. So faults could be, for instance, destructive, pressure, latency, and so on and so forth. So just to look at some of those more specifically, so this is the chaos agents. That is this agent-based. So this is the agent that you inject into your either Linux or Windows machine, and you can see here. So if you've got something that's specifically, say, for instance, memory bound, you could put some physical memory pressure into that VM to see how the system reacts as a result of that. And then I won't read through all of these, of course, but there's various things that we can go down here. Killing processes, DNS failure. It's always DNS. Well, it's not, of course, but you can put a DNS failure in. Network latency. If you've got things that are real-time specific that need, say, for instance, API testing is a great example of that. If that channel times out, what happens to your application in that time? And then obviously disconnection and firewall rules. There's a bunch of good stuff there. For direct faults, so this is where no agent is required. Again, this is this growing list. So we can have a virtual machine shutdown or a scale set instance shutdown. So that's the idea of say, okay, well, we've got 4 instances running, let's kill 2 of them. A region failover for Cosmos DB to make sure that your code still runs. Network security group, change the rules, make sure that things still apply. And then a couple of others that are there around Azure Cache for Redis, a reboot. And then one fairly new one actually, which is about Key Vault, so denying access to Key Vault. So if you can't get the secrets that you need, how does your service react? And then there's some other stuff around AKS as well. So again, these are very specific to AKS, of course, and it does require Chaos Mesh. So that's an open source thing from the Cloud Native Foundation, and essentially you can just install that into your AKS cluster. I mentioned here that Helm is easiest because that's usually the easiest way to install stuff. But essentially what we're doing here is we're installing something that allows us to act or enact across the entire AKS cluster. Right, so here's a resource group. Here's one I created earlier. But before I go into this resource group, what I want to do is I want to go to a GitHub repo that has been created by one of my colleagues, a gentleman by the name of Scott Holden. I have to call him out because he's done a great job with both this and with the slide deck as well that he's been mostly responsible for. So give big shout out to him. However, this is his repo, and it's a great little thing because you can actually deploy this directly into your Azure subscription. So if you want to have a bit of a play generally with Chaos Studio, this is a great place to start. So I just want to have a quick look around this, just to show what we're doing in our demo. So essentially, we've got this really, really simple website. It's running in, in fact, let me go back to here first and just describe what the demo is. So we have a VM scale set, which is running 4 instances. That's all just running a very, very simple website, which I'll show in a second. And we've got app gateway in front with a public IP address. And then we're going to run an experiment against that. And you can see here, you can just click this directly to deploy it. So this is a really, really simple website. Essentially, all it does, it creates a very, very simple graph. And I'll just show that in a second. But this website just essentially hits the public IP address of the app gateway, which of course gets it sent out to the 4 instances. Those come back and we just log the amount of times that we get responses from those 4 instances. That's really all this demo does. It's very, very simple, but very, very effective. Now, you recall I said this is all bound into ARM templates. So I'm just going to go into here and go into the Chaos Studio part of Bicep here. I'm showing Bicep in this particular case, but it's obviously just another flavor of an ARM template. And if we come down to here, we can see the shutdown experiment. And we can see that what we're doing is we've created a target, we created a step, we created a branch, and we're doing something. So this is 1 minute. We're going to do an abrupt shutdown of instances 1 and 3 of the VM scale set. So you can see how it's very, very simple to create this. And then, of course, this means that it's very easy to then put in your CI/CD processes. The only other thing I'll show very, very quickly is the way that this works in terms of the way the website is set up. So it's just a really simple install of a website, and it just runs on port 5000. So that's the repo. So if we go back to the resource group here, we can see that we've got an app gateway. Let's go into backend pools here. This app gateway has a backend pool which is pointing to the VM scale set, which is that VM scale set there. So if we just go to that VM scale set, here we go. We can see that we've got these 4 instances and they're all running. So I'll just leave that there because that's the important screen. So what are these things running? These things are running a website. So this is the website as it exists. So this is the front end IP. So if we just go straight to the front end IP, this is what we see, and you can see it's just counting up instances or essentially pings on that website. So if I refresh this, it all starts from 0 and it just starts building this graph, and it's all very good. So that just keeps growing as time passes. So if we just take a quick tour of Chaos Studio, here we go. So we can see that in Chaos Studio, we've got targets and experiments. So if we go to targets, loading. What it does is it looks into your subscription and it shows you all the instances of things that are currently available to be enabled for testing within your experiments. So here we've got a virtual machine, so we can go into here and manage actions. So within a virtual machine, because it's got an agent installed, we can either shut it down, which is that service-based approach. So so from an ARM perspective, send a kind of a kill request or a shutdown request to that VM. And then here we have all those things that we can do with inside the service itself. So we can say, okay, I want you to apply a certain amount of pressure to the CPU for a certain amount of time to see how the system reacts. Just a quick look at an AKS cluster, just to show that does in fact come up with the, here we go, with those chaos mesh actions. Redis cache, we won't go into that because it's just a really simple one. If we go down to the VM scale set, so this is one I did previously. So in this particular VM scale set, I've actually installed the agent on all the instances inside the scale set, so I can do not only the shutdown but instance-based control of those agent capabilities as well. What we're going to do is we're going to look at this one here, which is the one that we've got in the demo today. And we can see again, we've only set up this for VM shutdown, and we haven't installed the agent on any of the Linux boxes. But we'll take a quick look at the experiment that's going to run. So here we have experiments. I can click create just very quickly to show the experience. Obviously, I have to put it into it creates an experiment instance inside my resource group, so I won't go through that process. But what we'll do is we'll look at this particular one, which is one that was created previously. If we click edit, then we can see we've got something set up for VM shutdown. It's going to last 1 minute. It's going to be abrupt, so just kill it. And we can do things like add new actions, false delays. We can add branches and we can add steps. And that's how you build out that experiment to run it. But what we're going to do is we're going to first off, we shall I'm just going to restart this as it starts from 0 because it's just a bit easier to see when the experiment is running. So there we go. So you can see the differences in as it climbs. So we're going to just start this experiment. So obviously it's pre-processing is queued, right? So if we go back to our scale set here, we just click refresh here. Obviously everything is still running because what's happening is it's kind of creating this instance and preparing the solution to run so that we're ready to run the experiment. So if we just head back here, it's waiting to start. And obviously you can click into here and you can start seeing what this thing is actually doing. There's nothing running yet, which is why it says no branches to display. And now it's running. So if we go to our scale set here and click refresh, we can see that instance 1 and 3 have stopped. If we go to our live instance demo, we can see that, and don't worry about the order of these. This is just basically the way that this graph is built. But this is obviously 1 and 3 anyway. But you can see that 1 and 3 aren't receiving requests anymore. And in fact, the requests on 0 and 2 are increasing. If I actually refresh this, we should see that it's only responding from the 2 instances that are still running. So that's clearly running and running to create this chaos that we wanted to show. And if we go back here, eventually, of course, this will stop running, and then we would expect to see the instances come back. And we'll just make sure that does happen. But if we just go into this details of this one now, you'll see that it is indeed running. So it's running, and we can look into this and we can see what it's doing and get some feedback. So it's running these targets. It's running that particular this on that particular target. And then hopefully, if I've been talking long enough, this should have nearly finished. I would imagine that those services are possibly coming back up now. Let's just check this very quickly. Yeah, so there we go. So the experiment is finished, and those instances are back up and running. And if we refresh this now, we should see the 4 graphs. It's not quite there yet. It's obviously in the process of coming back up. Here we go. Right, so there you go. So that's a very, very basic demo, and you can see it's pretty effective in terms of what it shows. So I'll just quickly head back to my slides now. I've only got a couple of slides left to go. So with that, I've just created a bunch of resources here. First one is just the general view of what that Chaos Studio can do. That's the overview. You dig in there, there's a bunch of stuff around samples and quick starts and so on and so forth. There's a really good article around chaos engineering in the well-architected framework, which is obviously part of the architecture center inside Azure. And then I've included a link there to Scott Holden's demo, live instance demo repo, so you can go and have a play and just deploy and start deploying your own experiments and have a play with a Chaos Studio, because it's really a lot of fun. And with that, I'll just say thank you, and I'll hand back to Simon.
Martin, thanks a lot for that excellent talk. Chaos Studio, chaos engineering, as I said up the top, a really interesting space, and as you said, something that's really become prevalent with the adoption of public cloud. I had a couple of questions for you that I was going to ask. You and I have kind of been in the industry for a while. We'll say long enough to maybe sometimes know better than we should do with some of the stuff we do. But thinking about chaos engineering and Chaos Studio, do you have a scenario from your time in the industry where you think something like this would have benefited a service or a solution to help improve its resilience?
Yeah, I do, and I think it's particularly pertinent to the environment in which we live. So, I mean, we all live in a country that's subject to some fairly extreme weather and events, and the one thing that springs to mind for me particularly is around fire and emergency services. Now we can wax lyrical about how terrible it would be if website A, B, or C could not transact and couldn't generate cash for the business. But for me, those life or death situations are the ones that particularly spring to mind as being directly relevant and important, as I say, particularly in our environment. I mean, we can only imagine what would happen, for instance, if you have your entire infrastructure and all of a sudden, because of a huge spike in fires and a need for calls to 000 and to dispatch fire trucks and so on, then of course you really need to be able to make sure that you absolutely are doing that, because if you're not doing that, there's a real risk to life. I will just throw one real world example that's not life threatening, but is interesting nevertheless. I think we can probably all remember what happened at the Australian Bureau of Statistics when they did the census recently. There was a lot of time when people couldn't get on because the back-end infrastructure just wasn't available because the volume was too high. So that's a great example of what can happen. But imagine if that was happening in a fire situation where you couldn't actually dispatch trucks and help people.
Yeah, and you do. I mean, certainly when you make even if you're taking a well-tested and well-oiled application from outside of the public cloud, there are some differences between a traditional hosting environment and a cloud hosting environment. I think sometimes people miss those differences because we took for granted historically that we had highly redundant infrastructure, at the host level, at the network level, at the data center level. We absolutely still have redundant of all of those things in Azure, but the way that you deploy and the way you utilize them is different. So you can't, for example, expect that your virtual machine will stay available because there are multiple power supplies in that virtual machine's host. Well, there probably are, but the way that the Azure Fabric manages the availability of services in the data center is very different to how a traditional data center would be managed with a hypervisor, for example. But you're right. Those life-threatening scenarios are the ones that where this sort of capability really comes home to roost.
Oh, exactly. But if you look at the general sort of stuff in our architecture center around the well-architected framework, it speaks quite heavily around resilience, reliability, and building for faults and failure, right? So because you're not in control of the hardware that underlies your application. So having the capability to test those scenarios, and more importantly, as a result of testing those scenarios, build that resilience into your solution is just obviously it just speaks for itself as to its importance.
Yeah. And it's about shared responsibility at the end of the day, right? I think you have a much better future for success in running in the public cloud if you're taking the opportunity to stress test your own applications and not just assume that where you're putting this stuff will deal with whatever gets thrown at it. And I think you and I probably have many war stories from applications that have just hit up against brick walls because they weren't really designed for scale out or even scale up or instance restart style scenarios. Look, I have one additional question for you before we get to the live Q&A. That demo that you ran there where you switched off a couple of virtual machines in a virtual machine scale set. The one thing I didn't see in that demo, and I'm guessing it must be a feature in an experiment settings, is really the duration of an experiment. Is it something that you turn on and it just runs, or is it something that you turn on and it runs for a period of time? And can you schedule them, in fact, because it could be that you want to only run these experiments at certain times.
So I'll come back to the question about scheduling because that's one I don't actually know the answer to. However, with regards to duration, obviously you set your steps up. Your steps can include a specific duration, and that could be whether that could be I want to last for a minute, I want to last 2 minutes, whatever, right? But then you have steps within a particular branch and branches as well. Right, so the experiment runs for as long as the experiment runs, based on the action that you're taking inside that experiment. Now, in terms of scheduling, it is ARM template enabled, of course, and you are starting the experiment. If you're doing that through you saw my example through ClickOps in the browser, that's just going to be called an API in the ARM resource manager. So whilst I don't 100% know the answer to scheduling, and I will certainly find out that answer. That's not a problem. Then I would imagine that yes, you should be able to do that through some kind of action.
We'll get the answer to that, and we'll put it into the show notes for today's episode. And it's a fast moving space because it's got an API. We give people the freedom to run their own, I guess, external chaos orchestrator, if that's even really a thing that we should be talking about, because surely the opposite of chaos is something being orchestrated. But anyway, I digress.
Yes, indeed.
Martin, thank you very much for today's session. It's amazing. For everybody who's watching, please do hang around because we're going to hop over to live Q&A where we'll take some of the great questions from the show today and talk through them. So Martin, thanks a lot, and I'll see you in a moment.
No problem. Thanks, Sam.